some people say it's not true, but it seems often when you read the news and stuff that the attackers have a huge advantage.
Yeah, it's a bit of a cat and mouse game like it always has been, because how can the defense protect against something that hasn't come out yet? So if an attacker finds a new vulnerability or a new technique or whatever it might be, they start exploiting it in the wild, the defense are the ones that have to go catch up. So it makes sense in a lot of cases. With patch management and stuff, like I guess in some cases we had a little time. We didn't have to patch immediately when something comes out, depending what it is, where you are. But that luxury is gone, because one of the things I love to do, and we've talked about this in the past, is patch diffing. And there are new interesting ways that people have come up with to end day vulnerability research. So those examples I just gave, I think those are really fascinating uses of the technology. What I don't like is in the arts and entertainment industry. I don't like people using AI to make music or to write screenplays or scripts or build images. I mean, all that stuff's cool, but like one thing humans are good at is artistic expression and just in general. And we don't want to lose that, but man, it's scary what that might end up doing to the industry.
In a perfect world, we wouldn't need DeleteMe to delete our personal data from the internet. Unfortunately, when something is free, like Instagram or even LinkedIn and YouTube, you are the product. But it even gets worse these days. You can pay for a product and you are still the product. Companies will still sell your personal information to data brokers. We've had examples of GM. You buy a very expensive car and GM have been selling your personal information, your driving information to companies, which affects whether you can get insurance or not. Your personal information is out there and you need to get it removed. Data brokers can legally collect and sell your personal information, your home address, your telephone number, your relatives' personal information. Lots of personal information about you is being collected and sold online. This can lead to bad stuff happening like scams, phishing, harassment, and even doxing. Now, you can manually go and remove your personal data, but you have to do this continuously, and I simply don't have the time to do that. That's why I'm using DeleteMe. It's a hands-free subscription service that removes your personal information from hundreds of data broker and people search sites. DeleteMe doesn't promise to solve all your privacy problems, but by removing your exposed, personally identifiable information from the public web, you are taking one of the most direct, concrete steps to reduce your attack surface. That's the core value of what DeleteMe provides. Get 20% off DeleteMe's consumer plans when you go to joindeleteme.com/Bomble and use promo code Bomble at checkout, or use the QR code on screen. That, once again, is joindeleteme.com/Bomble, code Bomble. I want to thank DeleteMe for sponsoring this video. Hey everyone, it's David Bomble back with the amazing Stephen Sims. Stephen, great to have you back on the channel.
Yeah, great to be here again. Happy New Year. I'm glad I got a chance to wash my hair today and not wear a hat. So
great to have you back, man, because I tell you, you're the guy that I talk to when it comes to like really cool technologies. And, you know, love it or hate it, AI is all the rage at the moment. But I believe you've got some cool stuff to share with regards to hacking AI. But just for everyone, before we jump into that, Stephen, you've been doing hacking, penetration testing, reverse engineering stuff for a long time, right? Just for people who haven't seen our previous videos, don't you want to give us like a 30-second about yourself? I know you're way too humble to tell us everything, but let me tell everyone who's watching, Stephen is the man that you need to go and watch if you want to learn a bunch of cool stuff, and go and sub to his YouTube channel, which I'll link below. But Stephen, give us the 30-second about yourself, and then let's talk about AI hacking.
Yeah, sure. I should have put a about me slide in, but that's fine.
No, don't worry.
Yeah, so I as David said, my background is mostly in the offensive space, reverse engineering, vulnerability discovery, exploitation, that kind of stuff has been my passion. So looking for vulnerabilities in browsers and kernels and word processing applications, things like that. But yeah, my experience has been red teaming, pen test, all that, everything kind of around the space. Prior to that, I was a network engineer. Like I still think to this day that it is a good thing to work in the general IT space before transitioning into security. It's not a requirement, but especially nowadays with junior positions being harder to find due to automation and AI and the expectations of having more experience, a lot of us, at least who are in my age group, started off exactly like I just said. I worked as a network engineer or a developer or sysadmin or whatever. And then as you're doing that, you're studying security, you're learning about business systems, and eventually you make the transition over. And that background and understanding of just general business is really, really helpful. But yeah, mostly vulnerability research. I run a weekly YouTube stream, or I try to make it weekly, called Off by One Security. And David's been super helpful with that, especially when I first started out. And we try to have guests on each week. I do solo streams as well, but a lot of times we have guests on, amazing people. Giving back to the community is the point, and trying to focus more on intermediate to advanced topics, just stuff that's more difficult to find, especially when it's niche, like, hey, a new vulnerability came out and here's the patch, and let's do a patch diff and understand a little bit about the vulnerability itself. So I'm also the SANS Offensive Operations Curriculum Lead at the SANS Institute. And I've been teaching for them for over 15 years and travel around all over the place doing that, which is a lot of fun too.
Yeah, I mean, it's sometimes hard to get you on the channel. So for everyone who, wants to see Stephen on a more regular basis because he's been traveling, can't always come on this channel, go and sub to his channel. I highly recommend it. Stephen does stuff that's amazing. And like Stephen mentioned, he does more advanced stuff. I often get comments on YouTube, this stuff's too basic. I knew about this 10, 20 years ago. So go and have a look at Stephen's stuff and then tell us if that interests you and if that's better, if you've got more experience. But Stephen, I've got to bring you back to the AI thing, right? AI is all the rage. You mentioned previously when we spoke, you've been working on something for about a year, I think, if I remember correctly. If you can take us down the road, hopefully at some point you can show us a bit of what you've been working on and sort of some of the issues with AI and also using AI, in offensive security or red teaming, hacking.
Yeah, for sure. It's a huge space. It's still in its infancy. I mean, machine learning, AI, and stuff like that has been around for a long time. You see in this example and this diagram, like if you go out to the internet and you search for what is a large language model versus natural language processing versus RAG versus what is vectorization, all that, you're going to get a lot of different Venn diagrams and kind of people's mental models behind how they view it and perceive things. And sometimes it's accurate, sometimes it's got some issues, but oftentimes it's whatever works for the individual trying to digest everything. And I know there's definitely developers out there who are experts in building this stuff out, but from the security side of things, you won't hear many people, if any at all, saying, I'm an expert at AI security, because we're still learning so much about the technology and it changes so rapidly that I would never call myself a subject matter expert of AI. I've been working in the space for as long as I could now and learned a lot of hard lessons, and we'll definitely talk about some of that. One of the questions, I'm sure you get it as well, David, a lot of times is, hey, I'm at university and I'm about to graduate, or I already graduated, or I'm trying to move over into cybersecurity, and it doesn't look like what I was sold on or told early on a few years ago, that there are all these jobs and they can't be filled because there's not enough people, and people are finding it's more challenging for many to land a position in cybersecurity these days. And I really don't think that we can blame AI for that yet, because a lot of these companies who are claiming to be AI powered, AI driven, or even products that do work, that are doing autonomous penetration testing or agentic this or that, companies haven't really been adopting that stuff so far. There's a lot of challenges in there around how to charge for it, because it's a consumption-based kind of technology where we're burning tokens and GPU and resources, and coming up with a way to, a lot of these companies also are VC funded, and becoming profitable is challenging. And even OpenAI, they're not profitable yet. I mean, you $20 US for a ChatGPT license, and if you're a heavy user, you're getting your money's worth and they are losing money on you. And so that's, again, one of the challenges. Trust and, again, confidence, regulations, benchmarks. There's all these reasons as to why I just don't think it's significantly impacting the job market yet. But we did have a mass influx of cybersecurity professionals coming in over the last couple decades. I've been here the entire time, and it's been amazing to watch it blow up. I think we definitely plateaued. That's my opinion, but I think we plateaued, and now we're kind of finding out what it's going to be like going forward, and how AI might disrupt a bit of that.
I mean, I'm glad you addressed that, because it is something that I hear a lot. If I start in 2026, or whenever someone's watching this video, the market isn't what it was. But I'm assuming it works both ways, right? You can the advice I would give a lot of people is, when you new to the industry, ride the wave, ride the new thing. And like you said, I mean, you've been doing this for a long time, and you feel that you're not an expert in AI, but that gives someone who's new to the field a new opportunity, right? So they don't go and do something that people have been doing for the last 10 years, rather jump on this wave and learn about this stuff because there are opportunities there as well. Do you agree with that?
Yeah, absolutely. And I've been telling people, because I don't think it's a bleak outlook for the future. I think there will be some disruption. There will be change. I mean, this is a huge time for technology, and one of the most transformational, if not the most transformational, that we've ever really experienced is the dawn of the internet. And there's a lot of speculation, but no one really knows how much of it's a bubble, which portions of it's here to stay. Yeah. And so I've been telling people, study the heck out of this stuff. We'll talk a little bit about the technology and some of the components of it today, but make sure you are out there building your own models using Qwen 3 and understanding all the terminology. And a lot of people are vibe coding and stuff. And, a lot of us find out that after we've been trying to vibe code something, it ends up just not being what we thought it would be and have to go rewrite the thing from scratch anyway without using so much AI. So some platforms and tools are great and people are having great luck and others are not. But I always say this as well, which is when I started off as a network engineer, there were some people who were much older than me at the time who were very complacent in their position. They were like, I've been doing this job for 20 years. I'm going to ride it out for another 10, 15 years and I'm done learning and that's fine. That used to kind of be okay, I guess, in some positions. But now that's absolutely not the case. I think for people who are passionate, motivated, are willing to put in the hard work, stay in the front of this technology, understand that with new technology comes new attack surfaces and be amenable, things are going to change, that there will always be work for you. But, to be determined on what happens out there. It lowers the barrier to entry. And you've got people who really don't have a lot of experience in vulnerability discovery and hacking even websites or whatever. And now they can create these offensive agents and they really don't know much about what those agents are doing, but they can spawn these things and have them go at a target, and it allows them to be more effective than they would be as just themselves. And you've got the force multiplier effect. And so the defense really has its work cut out for them right now because it's going to be hard to keep up.
No, I think it's a worry, right? Because it's some people say it's not true, but it seems often when you read the news and stuff that the attackers have a huge advantage.
Yeah, it's a bit of a cat and mouse game like it always has been, because how can the defense protect against something that hasn't come out yet? So if an attacker finds a new vulnerability or a new technique or whatever it might be, they start exploiting it in the wild. The defense are the ones that have to go catch up. So it makes sense in a lot of cases. With patch management and stuff, like I guess in some cases we had a little time. We didn't have to patch immediately when something comes out, depending what it is, where you are. But that luxury is gone because one of the things I love to do, and we've talked about this in the past, is patch diffing. And there are new interesting ways that people have come up with to end day vulnerability research, which end day, of course, is there's a patch out and someone has taken the patch typically and diffed it against the unpatched version of a file and found the vulnerability and quickly weaponized it. And knowing that a lot of organizations don't patch very quickly, so it can be as effective as a 0 day in some cases. Yeah, so let's talk a little bit about some of the just technology in general. Again, a lot of this stuff is subjective. It's difficult to get everything right, and the mental models people build out, whatever's helpful for you. Though, like I'll give one example. We'll talk a little bit about vector databases, and once you really understand it, you're like, oh, I got this. But for a lot of people, getting to the point where you really understand how it works in practice, it can be a little bit of a road to get there. But AI, we all know what AI is. I'm not going to go through and define every single component here, but I like these short definitions. I just put them together to try to be helpful. But like you think about in the past, we have unstructured data and we have structured data. Where like you think of a structured database, and we all know what those are. We come up with a SQL query to a Microsoft SQL Server, and we say select whatever from this, and I want to return all results from this database table and column and get the field associated with what I'm looking for, whatever it might be. And we can store all kinds of different structured data in there. It can be images and binaries and text or whatever we want. But most information on the internet is unstructured. Like you think of social media posts and most of the stuff out there, we can't store all this stuff in structured databases. It's just too much. So when vector databases came out, pretty fascinating. You want to definitely go and understand the maths behind it. I'll give an example, though this I'm telling you in advance, this is not a really accurate depiction, but it's helpful on getting your way there because it's something we can quickly digest, where we've got these vector embeddings and we have these arrays of numbers, and these numbers are meaningful. It's not like, let's take a photo of a beach, and on the beach, you've got the sun out, you've got clouds in the sky, you've got people laying out on the beach, maybe a couple dogs running by, and like we could have one of these values. It doesn't really work like this where it's representing like a label 1-to-1, like I'm about to say, but again, it helps with as a metaphor, where we could say a value between 0 and 1. It can also be in the negative, but this value in this array, maybe that represents the color palette, and we assign it a certain value, and the higher the value, the more meaningful to what it is we're trying to depict or capture. We're trying to capture the essence and the nuance and the semantic meaning behind things that are more complex, where there might be some trees and a high value. If the trees are very tall, we might have a high value for that tree being like 0.85. And then if there's another image, and if that's one value in this array, and if there's another image that doesn't have any trees in it, and someone wants to find trees, well, these like things are going to be stored together in like these clustered, and their neighbors are going to be close to each other. And there are these giant index databases, and it's just this training data. It all gets very complex, and there might be coordinates being captured. So again, not that simple, but if it helps build it out as a metaphor, as a mental model, we can kind of depict it as, okay, well, this value represents tall buildings. And if somebody wants to find tall buildings that also has a bunch of people walking around on the street, we can capture these different things in many dimensions, is my point. It can be thousands of dimensions, very complex. But I would suggest, like, go read, like, go look at a tutorial on YouTube or something about vector databases, and you can kind of start at an entry level and then work your way deeper into the maths as you start to digest it. But what it does is it allows us to store complex things, large amounts of things, much more efficiently. And it's pretty fascinating. You see terms like cognitive AI and large language models. I've got that line in there that says ontological use of domain-specific knowledge, inference, and situational factors to provide accurate results versus predictive AI. You know, these words, these sentences can just be confusing at first. They're difficult to digest. So I'll give an analogy that I like to use when talking about this, of like cardiology. So if you are someone who's experiencing arrhythmias or palpitations, you might go see a cardiologist, get a heart monitor put on you, which captures information and your EKGs and stuff like that a cardiologist is then going to go review. And from that, they're going to try and determine if there's an issue, and they'll diagnose you. There might be medication involved. And that's traditionally and historically how it works. They might get a peer review, second opinion. But just like in statistics, there's a margin of error. They could be incorrect about something. What if instead we were using AI and storing in these massive, these models, millions of patients with their EKGs and their diagnosis and medication they were on, and all those variables. Not only that, you've got the diagnosis from thousands of brilliant top cardiologists around the world. And if this model isn't poisoned and we can query this model, doesn't it sound like then we could be a lot more confident that our diagnosis is accurate, since it's not just a single doctor? Now, if we use the technology properly, it should be very, very accurate. I think that's a really cool use of AI. And when you get into like ontological, we're talking about pairings, like triplets, where we could say patient and something like has medication or is medication, and then a result on the other end. And like we can work through those. Again, I'm not a cardiologist, so I'm not going to go very deep there. But we can factor in the patient's lifestyle habits. Do they smoke? Do they drink? What is their age? Any hereditary factors? Gender, if applicable? And all that stuff can be used to get more accuracy. So like that kind of use is fascinating. Another interesting use of the technology that I've been seeing being researched is for academia, where you may have 20 students in a classroom learning maths, say it's linear algebra. And the way the teacher's teaching might work for half the class or 3/4 of the class. And they've got it. They're good. They're getting A's and B's and scoring well. But for a small portion of the class, it's not working for them. And yeah, it could be because they're not paying attention. That's definitely a factor, but let's not go there. But for ones who want to learn, it's stressful as a kid and even as an adult when you don't get something. And for the ones that want to learn, if it's not clicking for them, what is the reason for that? I mean, everybody learns differently. Some people learn visually better. Some people learn in an auditory manner. Some people learn by reading and digesting things at a certain pace. And where I'm going with this is imagine a kid, a student, having their own chatbot to AI interface, like LLM. They have their own trained model for the subjects that they need to learn. And it also understands many different ways that maths can be taught, because the way we teach math in the USA is probably different from in China, just different from maybe in Oman. And so a teacher can't take that time. We don't have that ability to switch context and adapt to every single student in the room if the way they're teaching is not working for everybody. But imagine now a child, for part of the class, works with that model. It has all their testing history, their grades and everything like that. Any other factors that it should be aware of. Uses natural language processing. Like, again, it's a simple example, but maybe the English vernacular or whatever language is being spoken is, since it's a 13-year-old, they've got slang, right? They're using different words. Maybe you can adapt and sound a little bit more familiar. I mean, that's just one small component. But so the child's being taught from this model and they're not getting it. The model adapts, or the chatbot adapts and starts trying to teach them in different ways and really figures out how this student best learns. And then they still are on computers all day. We interact with the teacher. We need the social dynamics of school and networking and all that. But like, that's another really cool use of AI. And really, it should be making people smarter. It should be giving you an edge, because you're almost getting like a personal tutor that is really understanding of you. And it should allow us to improve grades overall, make people smarter, even though in some ways AI, it feels like it's dumbing us down because we're reliant on it and we want to believe what it says is true and hope it's not hallucinating and let it write our code for us. So from that perspective, who's going to be becoming the next C++ guru who can question what AI has come up with, right?
So AI slop is the counter to what you're saying, right?
Yeah. And so those examples I just gave, I think those are really fascinating uses of the technology. What I don't like is in the arts and entertainment industry. I don't like people using AI to make music or to write screenplays or scripts or build images. I mean, all that stuff's cool, but like, one thing humans are good at is artistic expression and just in general. And we don't want to lose that, but man, it's scary what that might end up doing to the industry.
Exactly. Yeah. Yeah. Sorry.
When I was explaining a little bit about vector databases, like RAG is something that heavily relies on that. RAG, retrieval augmented generation, was the hot new thing that came out a while back. And it's trying to get more accurate results. It's using different, in real time, it can go out and get information, and newer versions have come out like CAG and CRAG and others, and they're trying to validate that what they are about to respond to you with is accurate. Like if you've used ChatGPT lately, you've probably seen that oftentimes it's like telling you what it's doing, thinking about this, checking on that and going there. And we needed to go and validate that what it's about to tell us is true to the best of its ability, because otherwise we got hallucinations. And of course, a hallucination is when it gives us a result that's just not true. Like one example I think I'll have on a slide coming up is a bunch of source code. And I said, can you find vulnerabilities in this source code? And it's like, yes, I found all of them. And there's hundreds of them. And I started looking into each one of them, and they were wrong. There weren't really vulnerabilities, none of them. What's the reason for that? Is it because we're using general frontier models that are supposed to know all of the things? Is it because we're not training something locally on our own, which is hard, getting good training data and working with it and reducing hallucinations and implementing a penalty system if you choose to do so? And, being someone that's been working in the space for a bit now, trying to build stuff, we're learning that the frontier models, and when I say that, I mean like Claude and ChatGPT and stuff, they end up doing a better job in many ways than training your own local model, depending on what you have access to and what your budget is and just a bunch of other factors. But we want to train, we want to work with the model, tell it when it's wrong, why it's wrong. Training is an important thing from a security perspective, obviously, because if we can poison it, we can get wrong information. Imagine my cardiology example, and someone poisons that model. That's going to be potentially life-threatening. All right, so let's jump forward a slide here. That's really just talking about some of the basics. So how are red teamers, hackers using AI and machine learning, stuff like that? There's offensive AI and there's adversarial AI. And most of us use it in the offensive space for offensive AI purposes. That is when we're using the technology to do things like you see on the slide, to make us a better hacker, to speed us up. It's like having a really smart co-pilot with us that can build things for us. Hey, I need a AMC bypass, a signature bypass for this EDR. And this one that was working isn't working now. Can you try to refactor it and make it work? And can you maybe even test to make sure it works before you give it to me? we're speeding ourselves up as an attacker. We're generating phishing campaigns and pretext, things like that we need. Voice cloning, just a lot of really neat stuff. When we get into, and that on the slide, by the way, that's Shell GPT, which has been out for some time, but it's just like a smart AI-driven shell that can help you as you need things. So prompt injection attacks would be an example of, most people consider adversarial AI, because adversarial AI is when you're attacking the technology itself, to summarize. Like offensive, we're using it to hack with. Adversarial, we're attacking it itself. And there's different kind of bug classes or vulnerability types that we can go after. We've all heard of prompt injection attacks, jailbreaking. I'll give you a couple examples of where you can go and practice this if you'd like to do so, because obviously you don't want to just go without permission and start trying to hack away at public models out there or private customer models. That you were seeing that a lot more now, right? In the old days, you used to go to a website and you'd have to call a phone number, talk to a help desk person for help or support. Then they started putting up a little kind of chat interface, but it wasn't AI driven. It was just kind of like it knew some FAQs and could get you certain information. Or maybe a live person comes across and has an interactive session with you, but none of that's AI driven. But if we make it AI driven and have an actual chatbot there, well, what is it that this chatbot has access to? Like, let's pretend that it's a cell phone provider, like a carrier for cellular service, and we authenticate to the website, and there's a support chatbot there, and I have questions about my bill. Yep. Well, if that chatbot is able to access data stored in a structured database, which oftentimes they are, then could I potentially get it to give me some other customer's information? Like, that would be a problem, right? We're trying to social engineer the chatbot just as we would social engineer a human, because it's trying to kind of act like a human. It wants to make us happy and give us the information we want. So if we can social engineer it, give up something it's not supposed to, that means we broke out of its guardrails. And it's difficult to detect when that does happen, because it shouldn't have happened in the first place. So if it does happen, it's like, how do you know if you tell 5 friends a secret, you know it's going to get out, but you don't know which one did it.
Yep.
So obviously, unless you have permission, you're not technically allowed to be going out and trying to break out and steal things. I mean, what people will do is, like, when ChatGPT came out day one, you could say, write me ransomware in C# and it would be, here you go. And then months later, you try to say the same thing and it says, no, I can't do that because ethics violations and stuff. So then we try to piecemeal it. We say, well, write me the code that encrypts files on the file system based on file type. And it will write you that code, because that code alone isn't ransomware. But if you are in the same context window and you ask that after you ask for ransomware, well, it's going to be like, hey, I remember you asked me that. I'm not going to give you this information. So you've got to get a whole new context window. And a lot of times along the way, even if it starts piecemealing it together, it starts to realize what you're trying to do and it tries to stop you. I mean, that's not like jailbreaking in the same way as trying to steal customer information, right? So there's levels to it, obviously. But it's fun. It's fun to practice. And you've got a lot of companies out there. I mean, not picking on developers, because being a developer, like a true staff engineer, it's one of the hardest jobs in IT, if not the hardest. It's very stressful. It can be. So if you have your developers have been working for the company for years, AI comes out and you decide leadership wants a chatbot. Now you're telling these developers who don't have a background in machine learning and AI to go learn this stuff and build it. What oftentimes happens in that case, we've seen it historically over and over again, such as with implementing a crypto system. They make mistakes. Security is an afterthought. They don't quite understand why something might be a problem. And then they expose this to the internet or internally, whatever, and people start attacking it. So it gives us opportunity. With all new technology comes new attack surfaces, of course. So
you mentioned you could practice somewhere, right?
Yeah, you can practice somewhere. This example here is an agent that my good friend and partner on the business side, Wasker Tejeda, wrote as we were building a component that was basically a chatbot hacking set of agents. And this is one of the agents playing the Gandalf CTF from Lakara, which is one of the ones you can practice on. They had the old version of the CTF, and then they have a newer version of the CTF. I believe the new one uses WebSockets and stuff, which kind of changes the way that you agentically have this stuff work. Just to point that out, agentic in most cases means you're removing the human from the loop, right? It's working autonomously. A lot of this stuff, you need a human in the loop. So I'll get back to that in a moment. But here you can see it solves all 7 or 8 levels, whatever, in under 2 minutes. And this is an old version of one of the agents we had. They're much better now. Yeah, so we'll get back to what I was just talking about. Some of the other examples, like one's called mini shot, where you're like abusing large context windows and AI starts to get confused. And you've probably seen it before, where if you don't click new chat when you start a different topic and you've been in an existing chat context for a long time, it starts to degrade in performance. That's why you typically want to set like a maximum context window. Like, it's one of the things from a security perspective, because you're trying to prevent certain bug types, or not bug types, but vulnerability types from being exploitable. Like model extraction is an example of an adversarial AI technique where a lot of models are API accessible, just like MCP servers often are. We're sending these small crafted prompts via the API, and we're just storing, almost like we're asking yes and no questions and just trying to enumerate the information and how that model's been trained, its internal logic, and essentially try to clone as much of that model as we can. Prompt injection, we just talked about that one. Is basically we're trying to social engineer the model into giving us something it shouldn't. Poisoning the model, that's pretty self-explanatory. If a company doesn't securely train its model, have a dev pipeline set up to do that properly, and an attacker somehow gets in there and is able to help with the training, or if you use public training data, you could be poisoning your own models. This is one of the reasons why ChatGPT is just not training off the answers. Like, a lot of times, a chatbot will tell you something that's incorrect, and you're like, no, you're wrong. This is what really happened. And it'll apologize. It'll say, oh, you're right. I'm sorry. It's not actually taking your correct answer and then taking that as gospel, as fact, and just updating this vector database. That would be dangerous, because somebody could generate thousands of PDF documents with false political information, and we all know where that goes. LLM denial of service is another one. Like sponge attacks is one example where we can submit malicious or computationally intensive queries. Like, one thing I didn't say before, when you are querying a vector database, your query becomes a query vector, it vectorizes. So we could say something like, find me new prime numbers. I don't know, numericine prime numbers, solve this really hard mathematical problem, take this college dissertation that I just uploaded in a PDF document and take each letter and each word starting from the first one and write me a whole new dissertation about this instead. I don't know, just making up some dumb example, but you're trying to burn tokens and exhaust resources, which is expensive. So all this stuff needs guardrails. We need ways to prevent people from doing this. Here's an example where to practice. I mentioned Lakera on the bottom and the Gandalf CTF. And then up top is an example of Crucible LLM from Dreadnought. It's a pretty cool platform and feature. Dreadnought, one of the guys there was Will Pierce. He left NVIDIA. He was the AI red team lead there. Started this company, Dreadnought, and they run this Crucible CTF, which is pretty, what you want to do is try to practice on the most real world version of the chatbot that you can try to jailbreak. And it gives you goals. Your goal is to leak out a specific thing. Some chatbots, breaking out could be as simple as, if I tell train my chatbot with guardrails to say, you are not supposed to say anything about politics, period. And then the challenge could be, get the chatbot to tell you who won the election in the United States in this year or whatever, right? And you can get it to answer that question somehow by keep changing your prompts. That means you broke out of its, what it was supposed to do. So that's an example. Some aren't very exciting. You're just trying to get it to do a very simple thing that it wasn't supposed to do. In other cases, it can be pretty fascinating. Like what we've been working on, the product's called ACID, ACID, and it's under Off by One Security. My buddy Wasker has been developing. And with the chatbot hacking agents, we'll just call them, we've been able to steal API keys, which we know what we can do with that, right? I can bill David instead of me for all my AI usage, my MCP stuff.
Yeah, exactly.
We've been able to obviously leak out and steal sensitive information. We were able to manage to be able to get a shell across it and the ability to issue commands on another computer. I'll go back to this for a second. I said before, if you are able to interact with a chatbot and it does something it was told not to do, there's not some alert that's going to be sent off to a SOC or somebody who's going to see that, because the very fact that you were able to get it to do that means you broke out of some guardrail somehow, and there's no way it wouldn't have done it in the first place, right? If that makes any sense. So what happens, what we found out that happens through an experience is that if you've got agents run like agentic kind of interactions that your hands are off the keyboard, and these agents are malicious and they're having a conversation with a chatbot and they're giving malicious prompts. Those malicious prompts are probably going to trigger the chatbot's going to know that what you're doing is weird. So it could, in that case, send some alert off to someone to say, hey, this person interacting with me is dodgy. Yeah. And so in this example, we couldn't see the other side, so we don't really know exactly what happened, but we got some, I'll just say, things we shouldn't have been able to get credential-wise. And it's because one of the agents embedded some JavaScript into the prompt, which rendered on some administrator, I guess, who was monitoring the interactive session to try and see what's going on because it was alerted by the technology. And so we were able to steal something from that individual. That's strange. Never seen that before. But stuff like that becomes quite interesting.
Can you just explain this, Stephen? Because I'm slow. So you were attacking an LLM or like a chatbot, right? And maybe someone got alerted, and through that chatbot, you were able to sort of reach through and grab someone's credentials. Is that kind of right?
Yeah. So whatever they were using, I don't know if it was a browser or some custom thing. I have no idea, but it allowed and rendered the JavaScript, and it executed on whatever that person was using, which was able to pull some information off of that system. Again, we're still trying to figure out what the heck even happened because that was unexpected. Yeah. But I'll tell you though, because I think it's important to point out, that is one of the reasons why some companies or a lot of companies are going to be hesitant when people say agentic, autonomous, because we can tell a human pen tester, this is the scope, only touch these systems. This is your rules of engagement. And if you come across something that you're not supposed to, maybe you're not supposed to look at PII data, but you found something somehow, as a professional, you're supposed to disclose that in case there's regulatory concerns or privacy issues. A agentic platform, even though you told it the same kind of rules that you tell a human, how do you know that it's going to stay in scope? How do you know, how confidently can you say it will never break a rule? And if it does,
it's non-deterministic, right?
So that's why I think earlier when I said I'll go back to this is what I meant. When it comes to the job market, as this technology starts to get adopted and companies start feeling more comfortable, it may very well affect sizes of teams. If we can prove that a forward team of 20 offensive engineers, we'll call them, at our company, it's expensive, right? Most people 6-figure salaries.
Yeah.
And if we can demonstrate that there's a product out there that can do a certain percentage of these individuals' work, and it's cheaper and maybe even more effective and more thorough, and it doesn't sleep, then we could reduce that team down and replace it with this technology. And then the people who are still there, their job would change because there's some things that AI is not going to be able to do, but also those individuals will need to be doing governance and validation and being the human in the loop to make sure things are staying on track, to validate findings, to read the reports, to make sure everything's accurate, because a lot of this stuff can be automated. But again, we don't know exactly what that's going to look like. We can speculate. I don't know of any companies that have really adopted and replaced people who are in the offensive space with a product, because a lot of these products could only do a subset of what a human pen tester might be able to do. There's products out there that just do web app testing. There are products out there that just do AI SAST. There are products that just do AI API testing. And a lot of these products out there claim they're AI driven, but they're really not. Some are, and some aren't, because the vendor wants to slap that AI tag on it. And
exactly.
The only AI they might be doing is taking something, giving it to a frontier model, getting the result, and giving that back to you. Not doing anything more than you could do yourself. But then they can say there's AI involved. But what we've built, some of it requires a human in the loop. Some of it's fully agentic. You just have to tell it what to go do. And it is very much AI driven because we see the tokens being burned. We know, I'm intentionally being careful with my words because there's stuff with NDA and secret sauce that you don't want to give away, because you've got all these different companies out there, some that are VC funded, some that are not, and they've got their developers and at varying levels of cybersecurity experience and involvement. And the way that they go and implement their product that's AI powered or driven is probably going to be very different than the next person over. And some are going to get better results and keep the costs down. going to have better margins. Some are going to be more thorough in their testing. Some are going to have more capabilities than others. So as you'll see out there, as these companies come out, many of them require tight NDAs currently. They're cautious as to what they share because there's a lot of companies and VCs are seeing this as a very lucrative industry in the future.
Yeah, it's interesting because it gives you a lot of opportunities. I think, as we were saying earlier, people who are interested in this field or new to this field, opportunities that they perhaps wouldn't have had.
Yeah, exactly. I mean, there will be new jobs. Like, I don't know what it's going to be called, but it could be something like AI offensive orchestrator or something. And those individuals are going to have a lot of experience. Like, they're going to need to be experienced and seasoned pen testers or red teamers, because remember, they need to do the validation and say this is right or wrong and deal with hallucinations and deal with regulatory issues and validate reports and give the prompts to stay in scope. And there's a lot to it, and set the thing up in the first place. Some of these AI platforms out there, if you want it to be effective, that vendor may say, we want you to disable certain security features that you would normally have up so that we can thoroughly test things, assuming that we were able to get in, like demonstrate the true impact. And some companies might push back and say, well, that's not real world. Well, that's where like AI SAST comes in, where we heard of Aardvark from OpenAI not too long ago, hooking this up to your CI/CD dev pipeline and trying to find the vulnerabilities before they get published. So for zero-day exploitation, I believe we talked a little bit about this in the past, but this research will never stop. And the reason is because look at the price tags on the right. Like, this example comes from a company called CrowdFence, which is an exploit acquisition company out of Dubai. There are many of these companies. There's one out of Russia called Operation Zero, and they pay even more money in some cases, but they say on their website, they're a non-NATO friendly company. So, if you're selling to them, you might be committing an act of treason.
Depends who's watching, right? Who's watching this video. But I'm assuming there's a lot of people in the US watching this. Yep.
Yeah. I mean, that's why I try to stay away from anything to do with legality concerns, because it's so different in every country. Like $7 to $9 million US for a iOS, like iPhone or iPad exploit chain that's zero click, meaning I could just like send you a text message and it somehow gets past the blast door security in iPhone, iOS, and roots the thing, jailbreaks the thing, and installs Pegasus. Like, that's when you're going to get $7 to $9 million US. If these are the proxies, the intermediaries that are buying from you on behalf of their customers, imagine what their customers are willing to pay.
Exactly. Yeah, exactly.
But the point is, this is why this research will never stop. Like, some people also ask, like, hey, I talked a little bit about, I will talk a little bit about actually Google Project Zero's Big Sleep project. And they've had pretty good success, and it's getting better and better with autonomously finding 0 days that were once very difficult to find, like heap overflows, like just more advanced bugs, and weaponize them. And so, there's a lot that comes with that related to the price tags that we're talking about, and fixing this stuff before it gets out to release. And people ask, like, will AI be able to do all that stuff and will replace researchers? No, there's always, like, I believe I mentioned earlier with music, you can make songs. You could say, I want AI to write me a song like Linkin Park. Yeah. You're not supposed to say the literal band, but you could say something like, hey, in the nu metal genre, from the top bands of that era, I want you to write me a song that sounds like one of the top 10 hits over the last 20 years in that genre. It does a really good job mimicking and writing a pretty good song. It's like kind of scary how good it is, but it's mimicking in a lot of ways. It's trying to write something that's already been written, but that's new. It's not like, I think it's less good at, like, what's a big band that's really original that's come out over the last 10 years? Can you think of one?
You're into music, you tell me.
Yeah, I'm into music, but I should know it.
You're asking the wrong person. Sorry, go on.
Like David Bowie, right? I'll give a classic example. Like
Bowie,
amazing. Yeah. Or even like Black Sabbath, right? Ozzy Osbourne. Like, those were so unique when they came out, and the voice was unique and the sound was unique. So I think there's still going to be new bands coming out that sounds like nothing that's been done before. AI is not going to be as good at trying to create that. That's where like the human element comes in. My point, and tied to here, is there's a lot of nuance and creativity that only, at least today, humans can bring. Once we reach AGI, that'll change, I guess. So yes, there will always be researchers. There will always be jobs for senior people. There will always be hone to own interesting challenges that are coming out. And a lot of it's due to these price tags. Real quick, exploit mitigations do not fix the root cause, which is the bug in the code that's exploitable. What they do is prevent exploitation of that bug through different means. And there's different categories of them. There's dozens and dozens of them now, both in user land and in kernel land and in the hypervisor layer. And when these things all work together and they're all turned on, it adds really good defense and depth and makes it oftentimes impossible for an attacker to exploit the vulnerability that's there. Now, if you find a vulnerability like that, but you can't exploit it, the vendor will still patch it. It's just not worth as much money, if any, because you can't get around these mitigations. Like an example that's very mature is data execution prevention. It prevents you from executing any payloads or code outside of the code segment. And the code segment doesn't have the write permission turned on. So it's trying to protect things in different ways. And these things are very effective. And again, that drives the price tags up. I've shown this in a couple presentations now. When I spoke at DEF CON in 2024, so a year and a half ago, I guess, MSRC was kind enough to give me this diagram because I was trying to demonstrate how attackers move around as mitigations come out. And I didn't know what this image was going to look like before they sent it. And luckily it did depict what I was hoping it would. Over on the far left, you see the big high percentage area is the light green one. And then it starts to shrink down over that 10-year period. Why is it shrinking down? Because that's memory corruption bugs, memory safety issues like use after free and type confusion. And a lot of the compiler developers and OS developers put in mitigations that really mitigated a lot of the exploitability in many cases. Like, for example, Microsoft added to their Internet Explorer and Edge browsers at the time, 10 years ago, controls like mem garbage collector, where it pretty much kills the exploitability of most use after free vulnerabilities in the browser. Stuff like that. So that's why you see the percentages of overall exploitation going down in some areas and moving around as new things are discovered. Somebody finds, hey, there's a bug class called double fetch, which is a TOC/TOU bug class. And then once it gets exploited, they try to go and mitigate that. And sometimes they completely kill a bug class through the mitigation. So it's pretty cool. So real quickly, Google Project Zero, shortly after ChatGPT came out, they started to work on a project to automate using AI to do vulnerability discovery. And at first, as we've seen historically through DARPA projects and others, finding low-level bugs, low-hanging fruit, like buffer overflows and things like that, format string bugs, that's pretty easy to automate. And it's also easy to find those in source code scanning tools, like static analysis. But the more complex bugs, like the ones I was just describing, use after free, type confusion, double fetch, or logic bugs, those are harder to find in an automated manner. So their project was aimed at building up a framework to, again, try to use frontier models or locally trained models or both to find vulnerabilities, to drive fuzzing test cases and just automate the whole thing. And they called it nap time, I imagine, because, hey, if we can get this working, we could take a nap while AI does our work for us. As they went along, they changed the name to Big Sleep because they had really good success. So now we go sleep for a long time. And back in October 2024, they found the first 0-day autonomously through their project against SQLite. It was a Stack Overflow, but it found it autonomously, weaponized it, or demonstrated a proof of concept trigger code, and it got a CVE in 2025. They continued and found vulnerabilities in the V8 JavaScript engine, like Chrome, which is pretty amazing. FFmpeg and ImageMagick, if you've been watching X or other platforms and all the buzz around that was going on a couple months ago. 20 vulnerabilities discovered when I wrote this slide anyway, back in August 2025. That's pretty neat. So it demonstrates that this stuff works. I already mentioned this about hallucinations. This is that example. I gave it Lenovo driver code on the left, and I gave it a simple prompt. Can you find vulnerabilities in this driver code? And look what it says on the right. And that's just a snippet. It was like, yes, I found all of them. And I started looking into some of these, and most of them are just completely flat out wrong. Hard-coded magic numbers, well, that's more informational, right? But something like potential buffer overflow, number 3 on the slide, it says the function directly uses the result of file get size stored in variable 25, blah, blah, blah. It doesn't have enough context to claim what it's claiming. And that's not the fault of AI necessarily. Sometimes it is, sometimes it's not. Like, does it understand the cross references, and did it really go through and map things out in the relationships, cross references, like I said? And obviously, if this is static, it doesn't have runtime context, so it can't debug it if it's just like a generic example like this. So you're going to get a lot of hallucinations. What a lot of people will do is scope things down. So I always say this, which is like, humans, we're better at being experts at one or two things versus trying to be experts at all the things. Go into a hospital, there's not one doctor that does cardiology, oncology, neurosurgery, ER, all that stuff, right? There's many doctors that specialize in pediatric oncology, urology. And so just like we can scope and focus humans down to a specific area of focus, like AI works better that way too. We have different agents focusing on different problems or different bug classes, and they work together. They have memory management and all. The point overall, the takeaway, by spending the time training and scoping down an agent to focus on certain things and be an expert at like C++ in this example, you tend to get better results. It doesn't mean it's perfect. You still have to continue to train it and improve it, but you eventually, hopefully, get it to a point where you don't have to deal with these false positives all the time, because these are huge wastes of time. This is just a simple example, again, kind of summarizing, but there's a project out there. It's been out for some time called Crew AI, and it's really neat, especially for someone who doesn't want to go and have to build things from scratch. And you want to be able to create several agents that all work together to satisfy like some pipeline. Like, you could have one agent that's a cyber threat intel agent, another agent that's good at certain bug classes, or another agent that its job is to go out and get all the latest CVEs and put some context to them, or store patch diff results. And these different agents are supposed to all work together to like automate and have some pipeline capabilities. So it's a neat way to get started with this. This one here, I'm not going to do this justice like Caleb Gross did, obviously, because this is his project. But this is something we're seeing more and more of. Like, just recently on X, a couple weeks ago, there was a post saying that someone was able to solve an algorithmic problem around mapping the most efficient path to a destination, like from a starting point in a busy city to a destination, mapping out the most efficient path and quickly. And so it solved an algorithmic problem. And the kind of overall concept is to take complex problems and break them down into smaller sub-problems. And if you do it right, you get a lot faster and more accurate results. This is a project from Caleb called Rank, R-A-I-N-K. You can see the link there. I know he's done some updates to it since then. I saw him present at the OAIC conference in San Diego in October, and I was like, this is awesome. So I had him on the Off by One security stream. So if you go over there and you search for Caleb or Rank, you'll find the video, and it's neat to watch. But as you can see, it looks like it's sorting things upward, right?
Yep.
What he did, and there's an example prompt, he took a privately disclosed vulnerability, and I believe it was in like an IoT device. And a lot of times, so when Microsoft patches something, usually the file, if we extract it properly and we run a differential between the patched library and the unpatched library, and maybe there's 10,000 functions in that library, we're only going to get matches on like one or two or a handful of functions. So it shows us exactly where code changes are between an unpatched and a patched version of a file, as long as the only code changes were related to the security fix that they were trying to make. And so that way you can focus right in on the root cause and figure out what the vulnerability is that they fix, and you can try to go weaponize it. Microsoft is nice, and it gives us debugging symbols and all, and it does security fixes that way. Most vendors don't. So in a lot of cases, if you have something like a firmware image and it's got libraries or executables and stuff in there, and there's been a patch made to it that's a security fix, oftentimes there's a lot of feature changes and other code changes, so that if you do a patch diff now, instead of just getting one or two hits, you get like hundreds or thousands of functions that have code changes, which leads to a lot of distraction and false positives. So as I was describing earlier, if we break things apart into smaller groups and start ranking things, what he did was it gave that prompt there. So that prompt came from the vendor who disclosed the vulnerability that was privately disclosed, and they put the patch out, but no one knows the technical details. So he used a prompt that partially included the advisory: an improper authentication vulnerability in the SSL VPN authentication mechanism allows a remote attacker to bypass authentication, so on and so forth. That's the prompt he gave it, which came directly from the vendor. Using his tool, it does the differential, and then it takes relationships where code changes have been made. The AI goes through and annotates the code to try to like decompile it and add comments to say, what does this code do in these functions? And it starts bubbling up and ranking out of those groupings which one is most likely associated with the vulnerability given in the prompt. And as you can see, it works quite effectively and bubbles up to the top at the end, the function that was the culprit, that was related to the vulnerability. That's super cool. You don't even have to do it for patched vulnerabilities. You could like assume that there's a type confusion bug in a Linux kernel driver. Maybe there's not, but you're banking on the fact that there is, hopefully. And this would be a 0-day example. And you use a tool like this, give it a prompt and say, there is a type confusion vulnerability. In other words, let it do its thing. And Caleb has demonstrated that using his tool, he's gotten success out of it. So like we're in an era now where because of the technology and tools like this and others, anyone can find a 0-day that historically has been reserved for someone with a lot of experience, which is both cool and
amazing. Yeah, no, exactly. It's amazing, but also scary because the wrong people could do it as well, right?
Yep. So we'll finish up here real quickly with web app and API. So finding vulnerabilities in web apps and APIs, and there's quite a few vendors out there that are funded, some are not, and they're currently selling. Some are in beta or alpha, but this stuff's going to continue to come out more and more. And a lot of them focus on a specific area, like just web apps, or just web apps and APIs, or just APIs, or just SAST or others. But you think about anybody who's done web app pen testing, like for APIs, for example, there's some decent bug classes over there on the bottom left, like broken object level authorization. As a pen tester, when we're looking at APIs, like say we got a Swagger file or something like that, and we look at the endpoints and we start trying to use Burp or other tools to craft up checks to see if maybe it's exploitable. Well, we need like roles that are associated with APIs. Like, and for those of you may not like, maybe want an example. If you use DoorDash or Uber or like on your mobile app, that's going to be API traffic that's going back and forth between your phone across the internet to the endpoints on some domain. And you intentionally craft things to test for certain vulnerability types. But as a pen tester, oftentimes, once we find a vulnerability, like, and that gets us what we need to allow us to advance to the next point or laterally move or elevate, we're not always great at being super thorough. Or what if our target has hundreds or even thousands of API endpoints? We only have so much time in our pen test. Like, we can't be thorough. So if we can automate this and keep the cost down and it's accurate and it's thorough, this would be a good use of AI helping us out in the offensive space. You know, the concern and this for people worried about the job market and stuff is that, well, if we have source code scanning tools and AI SAST and stuff like Aardvark, it's going to find a lot of the bugs that would have made it to production otherwise if companies are using it. And then the bugs that make it to production, there's already so many bug bounty hunter people out there on HackerOne and BugCrowd who are automating anytime there's a change to a website. They're looking at the delta and trying to be the first one that finds a bug to submit it to get the bounty. And now you add more AI into this and more people can get into this space and use these tools and these agents. Isn't that going to get rid of all the bugs? And we're going to be super secure. I mean, if it's doing its job right, it's definitely going to reduce over time the number of vulnerabilities that get published and the speed at which ones that do make it to the public are discovered. But everything's going to get faster, right? So to be determined, this is not like a 6-month problem. This is a multi-year problem or concern. Just some examples of existing AI-powered products. I'm not going to walk through all of them, but those are just some of the many that are out there. Like APISec, for example, I believe they just focus on APIs. And Expo, we've all heard of that one. Acid's the one that I'm working on with my partner, Wasker, under Alpha One Security. It does several things. Again, I can't say too much in the future. I'd love to come back and show you more, not to like pitch, but just to show you like capabilities and what this stuff actually means and looks like. But, you know, expect more of this stuff to come out. All right, so I'm going to show you a quick demo. Don't try to go to the website right now because it's not going to be up. I'm in a sandbox at the moment.
Okay.
And this is just a partial version of the product, which is Acid. And in this version, it supports API penetration testing as well as LLM chatbot penetration testing. So I'll just show you a quick example. If we go like into LLM testing, this is fully agentic. So once you put in the bug class that you want from the list down here, you can add additional instructions to the prompt. You can set the context window and maximum number of attempts and things like that. And you would start the pen test, and this would actually start interacting with the target chatbot and having that session. Like, again, just super high level example, can't show much right now. Another example would be around like the API penetration testing. And like from here, we can see that there was vulnerabilities discovered, and you can go and look at kind of what the information is around the vulnerability. You can generate reports. I mean, this is pretty standard for all the products out there, whether it be doing web applications or API. It's going to show you what it's doing. It's going to allow you to set some controls around it. Like for us, the API penetration testing requires a human in the loop. It's agentic once you get down to the level of when it's actually doing the testing, but you have a lot of capabilities kind of in your API specification settings. Like this is an example where I dumped the damn vulnerable restaurant project in here just as a example. It's an intentionally vulnerable site that's been created with a number of endpoints that intentionally have different vulnerabilities, like broken object level authorization or BOPLA and JWT security issues. And the way in which each platform or company vendor out there has decided to automate some of this stuff and how they use AI and the connectivity around it. And there's a lot to it. And there are some similarities between a lot of these products out there, but a lot of them do things very differently, is my point. And I'm intentionally being vague.
Yeah, no worries.
But you would be able to go in and choose the bug classes that you want. If you just want to focus on certain endpoints and you just want to focus on broken object level authorization or broken function level authorization, you can do that. And then you need to obviously validate that the connectivity is there, that it's successfully getting a token. A lot of products out there, you could have a web application firewall that starts blocking things. So the testing could be interesting, especially if you're coming from the same IP address or you've got a bunch of agents running at once. Some vendors out there I've seen, like, we have 500 agents that will attack your website at once. It's like, that sounds like chaos. Like more agents does not necessarily mean better.
Yeah, exactly.
So again, intentionally being vague, but what I'll do is come back soon if you'd like me to, and I'll happily show you more about how this stuff works, like so you can see some stuff in action. Again, not as a sales pitch, but as a, hey, if you want to understand where things are at in the industry and what the products are actually doing when they're communicating, limitations around them and guardrails, and what it means by validation and governance, and kind of the reports that you get from these types of tools, happy to go in and talk about that stuff.
That'd be great. I think it's a lot of people watching will be interested in, like, okay, how do I make either my own or how do I leverage this to make me more productive? So that'd be great. Yeah, Stephen, I want to thank you again for sharing knowledge and helping people, who are either new to this industry or perhaps are, disillusioned with the way things are going, and, showing them the opportunities. I mean, you guys are working on this tool, creating this tool, but there's also a lot of opportunities for other people, right?
Yeah. I mean, the sky's the limit. Always, like I said at the beginning, it really staying on top of this stuff. You do have to obviously balance things in life. A lot of people ask, like, how do you have time to do all this, stay on top of that, have a job, family, whatever. And everybody works differently. Everybody requires a certain amount of sleep. But for a lot of us, it is a sacrifice. I mean, there's no Olympic athlete out there that didn't sacrifice something to get where they are. And I'm not comparing us to Olympic athletes, but I'm just saying to stay relevant and be at the cutting edge and study, network. And I always tell people to pick an area to research, and it doesn't have to be AI related, but obviously that's a good area, and try to find a new attack surface or a new topic that either hasn't been looked at before or maybe only surface level, and dive deep into it. Publish a blog about your research, submit to CFPs at conferences, and become a speaker. Build your personal brand. And a lot of us start off as kind of antisocial in some ways. We will be introverted. You have to get out of that shell. You got to get better at networking, getting in CTFs, all that. But like if I were 18 years old or 22 years old or whatever, like trying to get into this space, I would be doing everything I can to network and study my butt off and just demonstrate that I can be extremely efficient by leveraging the technology and not letting it replace me, right? What can I do more of now and faster and more quality? And here are the problems I found and how I fixed it, getting into the maths behind it and, playing around and building out a model. Just, I think that for people, as I said earlier, who are motivated, should have no issue or, less issue keeping working in the future. I know there's a lot of, and this obviously isn't something that just affects the cybersecurity industry. This, as I mentioned, music and film. And a lot of people out there have kids going to university and the parents are like freaking out because what their kid went into university for is now like they don't know if that job's going to be there and how everyone has to adapt. We've heard Sam Altman and others say that they might get to a point where these big companies like OpenAI got to switch over to some universal basic income model where they are actually giving citizens a stipend each month because their livelihood has been replaced, the area of work. But I'm not I'm not worried. And I'm not saying that because I'm older, I've got a lot of experience and don't have to worry. I'm just not pessimistic about the future. And I'm a pretty cynical person. So I'm optimistic. I think it's going to bring a lot of new jobs and opportunity. It's going to allow us to work faster and do more amazing things. I mean, quantum's coming as well. AGI, there's a lot of problems that need to be solved. There's a lot of work to do. And I don't think it's going away anytime soon.
So, I mean, the question always is like, okay, I want to learn this stuff. How do I learn this stuff? I mean, I would suggest everyone goes and subscribes to your channel. So that's a great place to start. Are you sharing this kind of stuff on your channel? I know you do a lot of stuff. How did you learn this stuff? I mean, obviously you're leveraging your experience, but like, are you reading somewhere? Are you learning somewhere? How are you getting this knowledge?
Again, with the technology like AI, we're able to cut corners, right? We can get information fast and we can validate it and we can learn the way we want to learn. So everything's at the ready, but there's a million great videos and YouTubers out there that if I want to learn more about just how, what's an example from earlier, vector databases work, you can Google that or look on YouTube. There's hundreds of videos and find the person that explains it well, that works for you. And the biggest thing I always say is getting your hands on the keyboard and doing it. Like, you have to pay your dues at some point. There are shortcuts. There's networking we can do and we can try to optimize our learning, but we've got to demonstrate our capabilities and learn it, and don't allow it to, for lack of better terms, dumb you down. Don't just rely on AI to write all your code. I've seen it so many times and talked to many people where, they might have gotten it to work with AI, but it's not optimized in the best way. It's not as efficient and it's costing more money or it's slower, causing other issues. So still understanding the languages that you need to know at a very low level and being a proficient developer is something I would recommend for people going down that direction too, of being able to want to build out this technology. All of those things. I mean, obviously, if you can, university's not for everyone. I didn't go to university straight out of high school. I actually did for criminal justice, but that was another life off. And I went and got my bachelor's and master's degree well into my career just because I wanted to get it. For me, it hasn't helped me in any way. It hasn't got me any opportunities. So I think you can self-study and enough information is out there, and taking short courses and finding good YouTubers and things is all super helpful.
That's great. Stephen, as always, thanks so much for sharing, man. I really appreciate it. I love that you take all these years of knowledge and make it much easier for the rest of us to follow you. And, you don't talk down to us. You encourage us and you show us the way. So thanks so much.
Yeah, thanks again for having me on, and we'll definitely do one again soon.